So this is our circuit of a AC to DC converter with LEDs. The way this works is that we have a sinusoidal input here generated from this waveform generator. Here we can see that it's set to 60 hertz and 20 volts peak to peak. And we can observe that here on the oscilloscope, like so. And then what we have here is we have a circuit here that consists of four different diodes that basically rectify the input sinusoid, meaning that it makes all of the input entirely positive. So it takes that negative voltage and mirrors it to make it positive. And then we have a set of capacitors, resistor, and a Zener diode, which basically smooths out the voltage, so it becomes a DC voltage, which we can now see on the oscilloscope. So if we look here, we can see that the frequency here is 118 hertz, meaning that now since we've mirrored that negative part, the frequency now doubled. And we can also observe that the voltage is also around 5 volts here, with the difference around 411 millivolts here, with the highest peak at 5.2 volts. And also we can also see that the reason why we use the LEDs here as our diodes is we can actually see them flip back and forth. We'll see is that if you decrease the frequency, which is what we'll do now, decrease it to around 6 hertz, we can So if we decrease the frequency, we can actually see that the LEDs go back and forth blinking, and that's because the input voltage actually takes a different path, depending on whether or not the full bridge rectifier is rectifying a positive or a negative voltage, which is kind of fun.